Today, we're going to continue this discussion of logarithms. So we're in second part of Unit 6. We're on day 6. We'll do day 6 today, tomorrow, day 7. Today we're going to talk about logarithm properties, and I think one of the things we're going to do today is we did a lot of mental math before. If you had something like log base 4 of 16 is equal to x. We would rewrite that and say 4 to the x power is equal to 16. What's the x value? Well, the x value is equal to 2. Today what we're going to show you is we're going to show you that a formula that you can use for that and type it in your calculator instead when they're not quite that easy to do. So we're going to get that property. We're going to talk about some addition properties, subtraction properties as well as we go through today with kind of the whole goal here is to be able to solve logarithms, whether they're single logs or multiple logs and that type of thing. So the first thing we have is we have what's called the change of base formula. Change of base formula is going to allow us to take any log and essentially use our calculators to solve it. So it says log base b of a. Doesn't matter what that b is. Doesn't matter what that a is. I could have log base 4 of 16. My base is 4. My a value is 16. What the change of base formula says is then that this is going to equal the log of x of a divided by the log of x of b. Now you'll notice that this x value is going to become the same. So I could make this log base anything that I want to make it. Okay, don't write what I'm about to write down, but I could make this log base 4 of 16 over log base 4 of 4. Don't write this down, but you'll notice that what was my a, which was my 16 here, that goes in the numerator. What was my base down here was my b. That becomes that part of my denominator. And you'll notice that these two things are now the same. Has that helped us? In any stretch of the imagination, has that helped us? No. But what could I make that base be to help us? What's on our calculator? 10. Okay, so I could rewrite this as, well, that's going to be the same thing as log base 10 of 16 divided by log base 10 of 4. It says the same thing. As long as these two things here and here are the same, that's the change of base formula. I just want to make them something that I can do on my calculator. So now on your calculator, all you have to do on your calculator is hit log 16, close the parentheses, hit divided by log of 4, close the parentheses, hit enter, and I hope you get 2. You get 2? Because if you don't get 2, I'm going to stop the recording.
Yeah, it is.
Okay, good. So you get an answer here that's equal to 2. Which is what I said it should be. Okay. Make sure you can get 2 on your calculator. Everybody getting 2? This is called the change of base formula, and it makes our lives a whole lot easier to solve these. This one, obviously, we could probably do that one. We could figure it out. And you did that on your assessment. But if you're given something like this. So if we were going to try to figure out mathematically in our brains what the answer for this one is. Again, don't really need to write this down, but it would be 7 to what power is equal to 6.58? Well, I have no idea. I do know that it has to be less than 1 because my number is getting smaller. So I know it has to be less than 1, but I have no idea. But now that we have this change of base formula, we can use this change of base formula to do this. It's the log of 6.58 divided by the log of 7. Just keep in mind that your base of your log goes in the denominator. The base of your log goes in your denominator. Base is on the bottom. Okay, so now you grab your calculators and you go log 6.58, close parentheses, log 7 divided by log of 7, close the parentheses, and you have your solution. We're going to round it to the fourth significant digit. So the log is 6.58, close parentheses, divided by the log, not probability. Clear. Go away. Log of 7, 0.9682. So that tells me that 7 to the 0.9682, that is equal to 6.58. That's what that means. So you can always check your answers by taking 7 to that one. When I was doing the key for the assessment yesterday, when you had some of those questions, the way I was figuring out if I was right or not was doing exactly that to make sure that I had them correct. Okay. Everybody able to get that answer? Finally get it, Eve?
Oh, yeah.
There you go. All right, the next one's log base 7 of 23. Again, we want to know 7 to what power is going to be 23. So mathematically, if we think about it, 7 squared is 49. 7 to the first is 7. So it has to be somewhere between 1 and 2. 23 is closer to 7 than it is to 49. So it's probably less than 1.5. Might not be, but might be. So this is going to be the log of, what's on the top? 23 over the log of 7. Log 23 divided by log 7. It's more than that. 1.61. 1, 3. Out to the fourth significant digit. Change of base formula is huge. You need to be able to use this, and you need to be able to do it well, because you can kind of imagine where this is going, kind of with our next step. Okay, so why don't you go ahead and find the answer for number 3, and we should be able to move on after that. Miss Ryan went over and got me coffee today. It was so nice of her. Cafe au lait from the coffee house. So 2 to what power is 41? 2 to the 5th is 32. 2 to the, so it's going to be between 5 and 6.
Yeah. You hungry, bro?
So the log of
41.
41 divided by the log of 2. Answer is
5.337. No, 5.3576. Yeah, why would you lie to him, bro? I lied. Now look at
5.3576. Everybody good? Able to do the change of base formula? Questions with the change of base formula? All right.
We're like 4.
Now, to use this, we need to know some properties of logs.
Yo,
Oh my gosh, look at all this. This looks so painful. It is.
I don't think it looks that bad. Hey, bro.
It doesn't look that bad.
Why you not ready to
So, product properties. So, 3 different properties and then examples of each, but we'll put the examples later. So, the product property. Product property says this, that if I have log of b to the m times n, so 3x. M times n just means you're multiplying those two things together. 3 times x, 27 times 2, whatever. You're multiplying two things together. That's equivalent to taking the log base b of m, so the log base b of your first term that's being multiplied together, plus the log base b of your second term. Okay. And whatever that might be. Okay. So an example of this one. if I have log base 3 of 9x, that's equivalent to writing log base 3 of 9. My base remains the same. It's my first term. Plus the log base 3 of x. These are equivalent to each other. They mean the same thing. This is called going from single log to expanded form. So we have a single log, and we're taking it and expanding it. Generally speaking, we need to be able to go both directions, from single log to expanded, and from expanded to single log. We generally go this direction a whole lot more. We go from expanded form to single log a whole lot more often, because it helps us solve. Okay? That's the product property. The quotient property. Products you multiply, quotient you divide as single logs. Quotient, when you write it in expanded form, log base b of your numerator, m, minus the log base b of your denominator, n. So in product, you add, in quotient, you subtract. Should sound familiar. It's what we did when we did exponents. When we multiplied exponents, we added them. When we subtracted, or when we divided exponents, we subtracted them. It's the same thing. Right? So log base b of m divided by n is the log base of your numerator minus the log base of your denominator. That's, again, going from single log to multi-logs. So, again, if I have log base 1/4, this 1/4 is just my base. It's a bad base, if you ask me, but it can be a base. So log base 1/4 of 4/5. That's equal to the log of 1/4. Again, the base of your log stays the same. Of your numerator, 4, minus the log, the base stays the same, of your denominator, 5. Those are equivalent to each other. Single log to expanded logs. Need to be able to go both directions, and we'll practice going both directions here in just a minute. The last property is the power property. And this is the one that messes people up a lot. Power property says that if you take log base b of m to the p power, that you're going to take whatever that exponent is, and you're going to move it out front. And then take it times the log base b of whatever your base of your exponent was. Okay. Those are equivalent statements to each other. And mathematically, if you think about it, I've got, this was a 2, I would have log base m plus log base m, log base b of m plus log base b of m. Well, I've got 2 log base b of m's. So I think mathematically it works, makes sense. You guys don't worry about that type of thing, so I'm not going to worry about explaining that again. So if I have log base 2 of 8 to the x, that's equal to x times log base 2 of 8. Okay, so those are equivalent to each other. Hey. One's in expanded form, one's in a single log. And just like we want to be able to go from logarithmic to exponential and exponential to logarithmic, we need to be able to go both directions with these. So that's what we're going to practice on next. So if I want to take this log and I want to write this in expanded form, this is considered to be a single log. There's only one thing. It's just log of uv. That log, there's nothing there, so remember that has a base of 10. So my base of this one is 10. That's a single log. We want to write it in expanded form. In expanded form, we're multiplying, so it's the log base 10 of u. That's my first term, plus the log base 10 of v. Don't need to have the 10 there. I put it there. Doesn't need to be there. could just as easily get rid of that 10. That's the expanded form of that. It's from a single log to expanded form. The second one, if we have log base, the log of a over b, and we want to write it in expanded form, the base remains the same. Our numerator goes first, our denominator goes second, and we subtract them. So those two things are equivalent to each other. That's the quotient one. And then the power one. Log of a squared. We got the 2 there. So its exponent is 2. Our property says that that exponent moves out front. The base of the log remains the same. And the a goes there. And you're done. Nothing left to do. So all of those 3 that we just looked at, all of them just had one thing going on. You either had multiplication, you had division, or you had a power. Simple and easy enough to do. Where they get to be much more fun is when you have these combinations. We've got a ton of stuff going on within this question. So we've got log base 2 of a to the 4th b, and then that to the 4th power. So logically, if we think what we've got going on, I've got a power here to a bunch of stuff, and then I've got those being multiplied together. So I know I've got to have an addition sign in here somewhere because these are being multiplied. I know I have to have something out front, but where do we start with this? Do I put the 4 out front, or do you suppose I should distribute the 4 in? Distribute the 4 in first. Okay, so there's a discussion we had as a math department earlier this week. We do talk math in math department meetings, believe it or not. We discussed, do we put this out front first and then do this, or should we have you guys distribute it in here? The decision was, let's distribute this in there. Do you get, in the end, could you get the same answer? Yes. You would if you moved it out front first. However, there's more steps involved. We like less steps. So we're going to distribute this in there first. So I'm going to rewrite this as log base 2. What do we do with power to power with exponents? Multiply. Power to power is multiply. So this is going to be a to the 16th, b to the 4th. Okay, so there's step 1. We're not done. Now I've got this 16 and 4, and they've got these being multiplied together. So when they're multiplied together, this becomes log base 2 of a to the 16th. Do I add them together or subtract them? Add. Because the a to the 16th and b to the 4th are being multiplied together, I'm going to put plus log base 2 of b to the 4th. Is that done? It's not done because we have our a to a power. So where does this 16 have to go? Where does this 16? Out in front of this, right? So this becomes 16 log base 2 of a plus, what is this one going to become? 4 log base, there should be a 2 there, log base 2 of b. There's your expanded form for that one. Okay, I'll move it up so you can see it. It becomes a lot. Now, ultimately, what's the end goal? My end goal is for you to really to be able to go from this here, and some of you probably did it anyway, to go from here directly to there. You realize that there's a 16, so that 16 has to go out in the front of the A. These are being multiplied together, so I know I've got to put a plus there. That 4 has to go out in front of the B. combinations of them. Okay, so let's look at this. Boom, boom. So we got log base 2 x to the 6th over y to the 2nd. Okay, so my brain, as I'm doing this, because I'm lazy. You guys should know that by now. I'm lazy. If I can do this in one spot, I'm going to try to do it in one spot. So my brain is going, what do I have to do this in one spot? First thing I notice is it's dividing. So that tells me right away that I'm going to have x to the 6th minus y to the 2nd. But I also have x to the 6th. So that means that 6 has to go out in front of the log. And it means that 2 needs to go out in front of the log. Okay, so I've worked my brain through it now, and I know what I need to do. But I'm going to do it step by step with you guys. So it's log base 2 of x to the 6th. We're dividing, so it's going to be minus log base 2 of y squared. Now I have a power, so I know I can't leave that like that. That power needs to be pulled out front. So it's going to become 6 log base 2 of x minus 2 log base 2 of y. There's our solution in expanded form. Okay. Now, at this point already, some of you, I'm pretty positive, could go right from here to right from here. And if your brain allows you to do it, do it. If your brain doesn't allow you to do it and you have to write that down first, write that down first. You have to do what your brain allows. Okay, as long as you're not using chat. Questions so far? We're doing okay? Well, let's go the other way. Okay, so in the examples we were doing before, we were going from a single log to expanded form. In this case now, we're asked to condense it to a single log. And this is done far more often. Because eventually we're going to want to be able to solve these. It's going to equal something and we want to be able to solve. That's probably more. But in order to do that, we have to write single logs first. So again, I'm not tackling first, I'm thinking first. Tackle later. So I've got 6 log base 2 of a. So in my brain, I'm going, all right, that means I've got a to the 6th plus log base 2 of 6 log base 2, so I've got a 6 out front, so that's going to be b to the 6th. So now I've got log squared a to the 6th plus log squared b to the 6th, but they're being added together, so that means that I can multiply them together to getting log base 2 of a to the 6th, b to the 6th. That's what my brain is doing. Okay, and in my brain it makes sense. Okay, so now we're just going to work it out on paper to make sure it makes sense. This can be rewritten as log base 2 of a to the 6th plus log base 2 of b to the 6th. They all mean the same thing. And now because they're added, I can write this as a single log. A to the 6th, b to the 6th. That's the solution. We've taken it from expanded form and condensed it down to a single log by using those in opposite directions. Okay? One of the things you guys have got to start to get used to doing is thinking before doing. You guys get in the mode of just procedures, blah, 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 blah. Whereas if you stop and think about it for 4 seconds and kind of work out a plan, even while you're copying down the answer, writing out and figuring out your plan in your brain, and then execute the plan after that. And if you're thinking about all of that, as you're writing it down, thinking about what you're going to be doing, then your brain's going to connect and say, I can do this in one step. If it doesn't connect and you can do it in one step, then do it in the 2. But at this point, I've got a minus. That means I need to divide. I've got a 5 out front, so it's got to be a to the 5th. I got nothing out in front of the log base 4 of b, so it's just b. So what's my answer? Log base 4 of a to the 5th divided by b. There's your solution. And you're done. But again, if you had to write it out as log base 4 of a to the 5th minus log base 4 of b, and then get to your answer, there is absolutely nothing wrong with that. You get the same answer. It's just whatever works best in your brain. Questions with that second one? All right, so let's look at this one. We've got 3 things going on. Doesn't matter. You have 2 things going on, you have 3 things going on, you have 10 things going on. Goal is for you to be able to look at it, figure out what you're doing, and write it as a single log. What am I going to do with these things? Add them, subtract them, multiply them. Do they have any exponents with any of them? So it's just going to be log of x, y, z. All right, so the whole goal today was to be able to take these logs and recognize the properties and use the change of base formula when needed. Okay, these are going to take practice. This stuff just doesn't work into the brain. The assignment today is meant to kind of help you. Please work yourselves through that assignment today.